Here are the steps for the activity. In measuring the volt of battery, set the multimeter to voltmeter to 20 volt, and put the probe in the negative terminal of the battery, and also put the positive terminal of the battery. I got the voltage of the battery 8.48 volts. To measure the voltage of the LED, put the LED to the breadboard, and connect the probes of multimeter across the legs of LED. Set up a light source near the LED so that the LED can generate its own voltage. And I got the voltage 0.45 volts. Are the steps for this activity. In measuring the current of the circuit, set the multimeter to 200 milliamperes and put the LED to the breadboard. And connect the negative terminal of the battery to negative terminal of LED. Then, connect the negative probe of the ammeter to positive leg of the LED. And also connect the positive probe of the ammeter to the positive terminal of the battery. I got the 173.1 milliamperes current measured in the circuit. To measure the current flow between the negative terminal of the battery and the diode, connect the positive terminal of the battery to the positive leg of LED and connect the probe of positive ammeter to the negative leg of the LED. And then connect also the negative terminal of the battery to the negative probe of ammeter. I got 2.56 milliamperes current flow between the negative terminal of the battery and the diode. Here are the steps of this activity. Set the multimeter to 200 milliamperes to continuity testing. Put the probe to the near connected vertically. There is continuity in this connection. After that, connect the wires horizontally. There is no continuity at this point. After that, test the continuity of the paper. The material has no continuity. And test the lead of the pencil. The material has a continuity. Test the water inside the glass. The material has continuity. Lastly, test the continuity of the table salt. The material has no continuity. Are the steps for this activity. In this figure, insert the LED to the breadboard. Connect the connecting or jumping wire to the legs of the LED. And to measure the voltage across the LED, set the multimeter to 20 volt and connect the positive probe to the positive leg of the LED and also connect the negative probe to negative leg of the LED. After that, connect the battery to the breadboard. The voltage across the LED is 4.7 volts. Meanwhile, to measure the current flow in the LED, I arranged the circuit where the ammeter connected to LED and series. Connect the probes along the LED, then connect the battery to the breadboard. For the current measured, I got the value of 179.2 milliamperes. By using ohmmeter, for the resistance reading, just simply reconnect the ohmmeter to the circuit. The resistance value of the LED is 113 ohms. This time, I added 1000 ohms of the resistor to TG circuits. Connect the one leg of the resistor along the positive lines. The other one must be connected to the near of the one leg of the LED. And to measure the voltage across the resistor. The value of voltage across the resistor is 6.23 volt. Do the same to get the voltage across the LED. For both components I acquired voltage value of 6.23 and 1.99 volt respectively. The current flows between the positive terminal of battery and resistor is 0.2 milliampere. And for getting the between the LED and the negative terminal of the battery, the value is that the value of current is 0.2 milliampere. By getting the resistance of the LED, put the probes to the legs of the LED. By using the ohm meter, set the multimeter to 100 or 1000 ohms. And the resistance value I got is 159.3 ohms. At this point, I inserted a resistor with higher value ranging 100k ohms. Connect again the components to series connection. To measure the voltage of the resistor, connect the probes of the voltmeter across them. Do the same the LED. Put the probes to the legs of the LED. The voltage acquired to the both voltage value is 6.57 and 1.74 volts. In this moment, we will get the current flows between the positive terminal of battery and the resistor, and between the LED and the negative terminal of the battery. That's why we need to set the multimeter to the 200 milliamperes to get the current. The value I acquired, the current flows between the positive terminal of battery and the resistor is 0.5 milliampere, and it's the same the value I got to the LED and negative terminal of the battery. At this we will get the resistance of the LED by using ohm meter. That's why we need to set the multimeter to 100 or 1000 ohms. And the value I acquired is 123.1 ohms. Here are the steps of these activity. To get the voltage across the components, I the following steps for connection. Connect the wire to the one leg of the LED and to positive line of the breadboard, and connect also the other wire to the other leg of the LED and to the negative line of the breadboard. And set the multimeter to volt and put the probes the breadboard. The value I acquired of the voltage across the resistor is 5.4 volt. And put the probes to the legs of the LED to get the voltage across the LED, and same to other LED. I got the value of 2.9 volt and 2.98 volt. And getting the current flows in each LED, I did connect the multiple to series connection. The current flows in one LED is 5.4 milliamperes, and the same to another one LED that the value I acquired. Set the multimeter to 200 milliamperes to get the resistance of two LEDs. The fixed value of LED I got is 1.238 kilo ohms. And the value I got in another LED is 1.258 kilo ohms. In this figure of this activity, to get the voltage across the resistor, I follow what I did in previous activity. I got the value of 1.88 volt. To get the voltage across the two LEDs, I got the same value of two LEDs, 2.71 volt. For the current, simply reconnect the probes to series connection. I got the first current value is 7.5 milliamperes, and the second value is 7.9 milliamperes. By using ohmmeter, set the multimeter to 200 milliamperes or 1000 mA. The value I acquired of the two resistance of LED is 112.1 ohms and 112.8 ohms. Test steps for these activity. In this activity, TG used a variable resistor was demonstrated. The components were also connected in series connection. For getting the voltage across the resistor, put the positive probe of the multimeter to the one leg of the resistor and put also the negative probe of multimeter to other leg of the resistor. And put the battery to the breadboard and set the voltmeter to the 20 volt. And I got the voltage value of 6.1 volts. To get the voltage across the LED, put the positive probe to the positive leg of LED and put also the negative probe to the negative leg of the LED, and I got the 1.9 volt. And to get the current flows in the LED, put the LED vertically and put the probes to the legs of the LED. And set the multimeter to the 200 milliamperes. I got the current flows in the LED is 0.7 milliampere. And by using ohmmeter, set the multimeter to the 200 ohms or 1000 ohms to get the resistance of the LED. And I got 129.5 ohms. To measure the voltage across the resistor, arrange the LED horizontally and put the probes to the legs of the LED. Set the multimeter to the 20 volt and put the probes near to the resistor. I got the voltage across the resistor is 5.91 volts. To get the voltage across the LED, put the positive probe to the positive leg of LED and put also the negative probe to the negative leg of the LED, and I got 1.92 volt. To get the current flows in LED, arrange the LED vertically to the resistor. And set the multimeter to the 200 milliamperes, and put the probes to the legs of LED. I got 5.2 milliamperes. By using ohmmeter and get the resistance of the LED, set the multimeter to the 200 or 1000 ohms. And I got the 137.2 ohms. Here are the steps for these activities. For this activity, I was able to recognize how the LDR works. To connect the circuit, the components must be connected to series. Since the large has no polarity, I can insert directly the leg in any lines. Connect the one leg along the positive line, and connect also the other one in mirror to the leg of the LED, and connect the wire between the LDR and positive leg of the LED. Connect the another wire to the negative leg plot, the LED, and the negative line of the breadboard. To get the voltage across the LDR, set the multimeter to 20 volts. And put the probes to the legs of the LDR. And you can get the voltage value of 5.9 per volt across the LDR. And to get re-voltage across the LED, put the probes to the legs of the LED. Got 1.8 volt. And for getting the current flows in LED, I connect the probes of ammeter to series. I rearrange the circuits just like what I did when I measured a current. Set the multimeter to 200 milliamperes and put the probes to the leg of the LED. The current flows in the LED is 1.8 milliampere. By using ohmmeter, set the multimeter to the 200 or 1000 ohms, and put the probes to the legs of the LED. And I got 119.1 ohms. When I turn off the light, or when I put the LDR in the dark, the brightness of the LED is decreases. And I try to put the LDR in the illuminated room, the brightness of the LED is increases.